3-1, Part 1, Homework Tutorial. On the front side, I'll do the odd problems. On the back side, I will do the evens with you. The front side is all about graphing the system to solve the system, and also classifying the system as either consistent and independent, or inconsistent. So the first thing one should do or could do when graphing an equation, especially if you want to use the calculator, is to write the equation in slope-intercept form first, if they're not already there. So for equation 1, I know to cancel out 3x over here, it would have to be a minus 3x on the right-hand side, which means that the equation would say y equals negative 3x minus 2 in slope-intercept form. Slope-intercept form, for those who forgot, that's your good old-fashioned y equals mx plus b. So that means on equation 1, m is negative 3, and b, or negative 3 over 1, and b is negative 2. For equation 2, it's going to require multiple steps. The first being subtract 6x on both sides, so you would get 2y equals negative 6x plus 10. Then you divide everything by 2. So 2y divided by 2 is y. Negative 6 divided by 2 is negative 3. And 10 divided by 2 is 5. So m is negative 3 over 1. And b is 10. What you should recognize, well, they both have the same slope. That's going to play an important role in just a moment. So let's graph equation 1. Start with your y-intercept, negative 2, put a dot, label it, and then use your slope, which says fall 3, 1, 2, and notice I'm off the grid. So instead of falling 3, I'm going to rise 3, up 1, 2, 3, but then I'll go to the left. When it's negative, you do the opposite of what you traditionally do. Traditionally, we go up and right, but that's only if it's positive. If it's negative, you go down right, or you could go up and left. So when it's negative, you got to do opposite of what you usually do. So this would be negative 1, positive 1 as an ordered pair for my first line, and we would graph it. Now we graph the second equation, which has a y-intercept of 5. 1, 2, 3, 1, 2, 3, 4. Okay, so 5's not on here. I do know 5 would be up here, and the slope says fall 3, so 1, 2, 3, and right 1, so that would be here. 1, 2, 3, right 1 would be here. So again, when it's negative, you fall and move right, or you go up and move left. So this ordered pair is 1, 2. This ordered pair is 2, negative 1. And then we draw the line. So it appears that these lines are not crossing at all. It appears that they're parallel. Well, they have the same slope. So any lines with the same slope are definitely parallel. With that being said, since they're parallel, they'll never intersect. And since they'll never intersect, there is no solution to the system. And when it's parallel, you would say it is an inconsistent system. So number 3, we got to put it in slope-intercept form first by taking equation 1 and subtracting 2x. So you're left with a negative 3y equals a negative 2x because it was just 0 initially. Then you divide by negative 3, so that would give you y is equal to a positive 2 over 3x, because a negative 2 divided by a negative 3 is a positive 2 over 3. So that means the slope is a positive 2 over 3, and our y-intercept is 0, because there's nothing after the x term. For equation 2, I first got to subtract 4x on both sides. So that leaves me with negative 6y equals a negative 4x plus 3. Then you divide everything by negative 6. So y is equal to negative 4 over negative 6 is a positive 2 over 3x. And then positive 3 divided by a negative 6 is a negative 1/2. So this one isn't going to be so nice to graph. The second one's not going to be as nice to graph using slope-intercept form, but I can show you an alternate method in just a moment. Let's graph equation 1 first, because the y-intercept is 0, which is your origin. Then you rise up to over 3. There's another point right there. Or you could fall down to over 3 this way, and there's another point right there. Again, label your points. So 0, 0, 3, 2, or negative 3, negative 2. Okay. Now, if I want to graph equation 2, the y-intercept is a fraction, and I want my graph to be accurate. So I might, no, even the x-intercept is going to be a fraction as well. So with that being said, let's use what we have. So our y-intercept is at negative half, so that's about here. And you rise up 2, so there's 1, there's 2 halves, and over 3, so about here. And, or I could come down 1, 2, over 3, so right here. So we have 0, negative half for my y-intercept. And then we have 3 and what is that, 1/2 or 1.5. So it also again appears that these are parallel. And it is confirmed when we look at our slopes. One, they're both 2/3. So yes, these are parallel, which means again we have no solution and an inconsistent system. On number 5, to put in slope and intercept form the first equation, we would subtract 4x on both sides. So the equation would say y equals negative 4x minus 2. So my slope is negative 4. My y-intercept is negative 2. Again, slope is always over 1 if it's a positive, a whole number. For equation 2, you would subtract 2x on both sides. So you would have y over 2 is equal to negative 2x minus 1. When y over 2 is also the same thing as y divided by 2, so that means to move that 2, you would multiply everything by 2. So you would get y is equal to negative 4x minus 2. So that means m is negative 4 over 1 and b is negative 2. You should recognize that those are the exact same line. And if I am to graph it, here's my y-intercept. Go down 4. Again, I run off the grid. So let's go up 4 to 4 over 1 to the left. Again, when it's negative, you go opposite. It should slant towards the left. So since it's the same line, I would only expect one line on this whole graph. Which means that this system has infinitely many solutions. In other words, any point on the line is a solution. So when it has infinitely many solutions, the system is classified as consistent and dependent. So I did the odds on the front. Now I'm going to do the evens on the back. On the back, we're going to apply substitution method to solve the systems. To use substitution, you want to probably number your equations. Equation 1, equation 2. And look at each equation. Identify which variable has a coefficient of 1. So when I look at equation 1, y has a coefficient of 1. So get y by itself. So that means Take away 2x from both sides. And you would have y equals negative 2x plus 5 on the first equation. You're then going to take that negative 2x plus 5 and you're going to substitute it in the second equation in place of y. I don't know why it's not coloring what I want it to color, but okay. I don't know. So let's get started with that process. So I'm substituting negative 2x plus 5 for y in equation 2. Okay? So equation 2 was 3x minus 3y equals 3. So I'm going to open up parentheses in place of y, and I'm going to insert negative 2x plus 5. Bring down my equals 3. Now I can solve for x. So distribute my 3. So bring down 3x. Negative 3 times negative 2 is a positive 6x. Negative 3 times a positive 5 is a negative 15. And it's equal to 3. Now I'm going to combine 3x and 6x. And I get 9x. Minus 15 equals 3. Then I would add 15 to both sides. So I would get 9x equals 18. Divide both sides by 2. You would, 9. You get x equals 2. Now that you know what x is, you take x back into the revised equation 1. So y was equal to negative 2x plus 5. So now that I know what x is, I can find y. X is 2. So negative 2 times 2 is a negative 4, plus 5 is a positive 1. So the solution to this system is 2, 1. Make sure you check your solution to see if it works. Number 10, again, number your equations, 1 and 2. On equation 1 again, y is by itself. Well, y has a coefficient of negative 1, so it's easier to turn that into a positive 1. You first get rid of 2x on both sides, which would leave you with negative y equals negative 2x plus 7. Then divide everything by negative 1. So y is equal to positive 2x minus 7. So now, again, we're going to take this expression, 2x minus 7, and we're going to replace y in the second equation. So let's write our second equation, but open up parentheses instead of y. So we can insert our expression. Our expression is 2x minus 7. And now let's solve for x. We're going to distribute first. Negative 3 times positive 2 is a negative 6x. Negative 3 times a negative 7 is a, I know I said positive 6x and I wrote negative. Okay, negative 3 times positive 2, negative 6x. Negative 3 times negative 7 is a positive 21. Now, when I combine my like terms, 6x minus 6x is 0. So the only thing I'm left with is 21 is equal to 14, which is a false statement. So because that's a false statement, this system has no solution. This system has no solution. In other words, it would have been two parallel lines that never intersect. On number 12 now, equation 1, equation 2. Again, equation 1 has y with the coefficient of 1, so I will get rid of 2x on both sides. So equation 1 would now read y equals negative 2x plus 8. And now I'm going to take negative 2x plus 8 and replace y in the second equation. So let's rewrite the second equation. 3x plus 3 over 2. Get our parentheses ready to replace y with negative 2x plus 8. Now let's distribute. Bring down the 3x. So 3 over 2 times negative 2x is a negative 3x. 3 over 2 times a positive 8 is a positive 12. Again, we have a scenario similar to the last. We have 3x minus 3x cancel each other out. And that leaves us with 12 equals 12. So this is a true statement this time. So when it's a true statement, that means there's infinitely many solutions. In other words, any point on the line is a solution. All right, on number 14, we have equation 1 and equation 2. And look at that, y'all. Equation 1 is already solved for y already. Great. Now all we need to do is take this expression, x minus 5, and replace y in equation 2. Now, all these problems I've done, we always got y by itself, but you don't always get y by itself. It depends on who has a 1 in front. Sometimes it's x. So sometimes you would get x by itself. So it really depends on the scenario. It's not always going to be one size fits all. So let's rewrite equation 2. Open in our parentheses to get ready to replace our y with x minus 5. And now we distribute. So 2 times x is 2x. 2 times negative 5 is a negative 10. Again, negative 2x and positive 2x cancel each other out. You're left with negative 10 is equal to negative 10, which is a true statement. So that means there's infinitely many solutions. Any point on the line is a solution. This concludes your tutorial on this handout.